Howdy, IB Math. It is a little more probability. This was the second part of the first day of notes. I probably have videos about this, but I thought I would put it all in one place. So here we go. My family loves to play the game Catan. If you are a fellow Catan lover, then comment down below. But it all comes down to rolling 2 dice. Well, I mean, there's a lot of details, but you have to roll 2 dice. And so what can happen is you can get a 1, 2, a 3, a 4, a 5, or 6 on one dice, and then the same on the other. But and you look at the sum of the dice, and that tells you what to do next in the game. So in my make-believe little world here, I'm happy if I get a 5 or an 11. Well, so we can get a 5 by rolling a 1 and a 4. That would give me a sum of 5. A 2 and a 3 would give me a 5. A 3 and a 2 would give me a 5, and a 4 and a 1 would give me a 5. So there's 4 ways, and in Catan, the number 5 has 4 dots on it, which is why. Look at that. Okay, and now to get an 11, I have to roll a 5 and a 6, so let's see if I can get that in the right spot. Or I can roll a 6 and a 5, and so there's 2 ways that I can roll an 11. So out of the 36 possible things that can happen, and I was too lazy to write them all out, 6 of them, 4 plus 2, were something that would make me happy, and that reduces to 1/6. Okay, this game, or this idea, and the expected value is something that we've been having a lot of fun with the game Mantis. So I may make a video, I should have brought the game to school today, but I didn't think about it till too late. But what we're looking at is if once we find the probability, then we can multiply it by the number of trials and figure out the expected value. So if it tells us Michael Jordan made 83-ish% of his free throws, if he had 18 attempts, how many can we expect that he would make? Well, this becomes 0.8353 times 18. And as in the last video, I'm too lazy to go find a calculator, but plug this in your calculator and then we can use that to figure out how many free throws we expect him to make. Okay, this I'm sure I have done in the past, but it shows up again with probability. So the universal set is everything. A union B, this is me saying stand up if you're a boy or have a blue shirt. Okay, and so my boys all stood up, and then all my girls wearing blue shirts also stood up. This is saying stand up if you are a boy and wearing a blue shirt. So that meant that only my 3 boys that happened to have blue on that day got to stand. Okay, this one is A union B not. So A is this. Oh, by the way, I was making A the left-hand circle. Okay. B not would be everything outside of B in addition to that. So what this ends up doing is it becomes everything but that little crescent. Okay, A union B not. Well, this was A union B, so A union B not is all the outside stuff. Isn't that lovely? A not intersect B, so this means it has to be outside B, but it must be A not intersect B means it has to be outside A, but it must be inside B, and so that becomes this. A not union B not means anything outside of A, which becomes all of this outside of A, union with anything outside of B, which then includes that right there. So it's everything but this little bitty middle part. You could also say that this is A intersect B not. Those two. So see how this is A intersect B? This is everything but that, so it's the negation of all that. Okay, A not intersect B not. So it has to be outside both of them, and so this actually matches. These two are the same. Okay. And a class of 25 students, 16 like boba tea, 14 like iced coffee, 1 student doesn't like either drink, and 6 students like both. Okay, so we have boba and coffee. We have 1 student out here. We have 6 that like both. We have 16 that like boba tea, so don't put 16 here because this whole circle should add up to 16. So that means that's 10. This whole circle adds up to 14, so that's 8. What's the probability that the student likes boba tea? Well, 16 out of the 25. What's the probability that the student likes boba tea or iced coffee, but not both? Let's say these 2 places, so 18 out of 25. What's the probability that the student likes iced coffee given the fact she likes boba? So this is say the probability of coffee given boba. So now we can only live inside the boba world, and the probability that they like iced coffee is 6 out of this 16, or we could reduce that to 3 out of 8. It was easy to reduce, so I did. All right. Like, subscribe, comment, and go practice. Good luck.